Think we're live now. Let me see if I can hear myself in the first place. Also, let me turn down the volume here. Let's see. Let me see if I can hear myself. Testing, testing. Also, let me turn down the volume here. Let's see if I can hear myself. Hello, everyone. We are live now. I just had to burp for a second. Hello, GTX. How's it going, dude? I didn't expect to see you here. I thought you're not going to join today. But this is just going to be like a casual coding stream again, where I'm doing some of the problems. I'm now on day 6 as well on Advent of Coding. I did day 4 and 5 yesterday. I have a lot of catching up to do, so hopefully we can do 2 exercises today. As long as I can do 2 exercises, I can be heard. Plans changed, didn't help my sister. Oh, dude, you should go and help your sister. She needs help. And yeah, I mean, I've actually started this in the last half an hour as well. So this is actually a very, very simple problem. It's you get like a grid given to you, right? Like this. And the position characters here are your guard. They call a guard. And the guard just walks forward, right? It walks towards the decision, the direction that it's facing until it finds a wall. And a wall is this hash thing. When it finds a wall, you rotate 90 degrees to the right or clockwise, right? 90 degrees clockwise, I believe it is. Right? 90 degrees. Yeah. Turn right 90 degrees. So you keep doing this until your guard reaches out of board. When he reaches out of board, you just got to find out the positions that they visited. It's a very, very easy and simple problem to do. And I've actually got most of it done in the last half an hour. There isn't much to say apart from I get the input and I essentially just turn it into a 2D array, right, of characters, of cells actually. I have some cells here, so the cells can be in 4 different states. You can either have a guard in a cell, you can either have a wall, and you can have visited and unvisited cells, right? That's basically what we have. And from there, if we just apply a walking algorithm, it's very, very basic. And I'm actually trying to do that right now, so we'll see if it works. She cancelled on me just now. Oh, dude, that feels bad, man. When your sister cancels on you. And she's getting the help. Anyway, so the idea here is obviously I turn the input into a 2D array of cells, and I just want to find the initial position of the guard and walk until I find a wall, and then rotate. I mark all of the cells that we walked past as visited, and I rotate 90 degrees. That's it. And do the same until we reach the guard position's next position. The guard's next position is out of bounds. Once it's out of bounds, we've got the whole thing done, basically. And we should have something like this represented in Rust, right? So I think the aim for this is just to count the number of different cells visited, right? This guard will visit 42. How many distinct positions will the guard visit before leaving the mapped area? So it's actually, yeah, it's not too hard. But anyway, we have something that needs to go into a loop soon. So this is we get the initial guard position here. And then we start getting the next position where we add the guard position, the current position to the guard direction, it should be called here. Guard direction. There you go. Yeah, you add the guard direction to the guard's current position. Easy as that. And then we check that the next cell is either a wall, unvisited, or a visited cell, in which case it's fine. Well, that's it, right? So it can only be a wall, visited, or unvisited. It won't be a guard for sure. But if we have a guard, like if we have a guard here, we know that it should basically be an error in this case. And we are going to return nothing. I guess a result of something. Yeah, the reason why I always return if the next cell that the guard is going to visit as a guard in it, then that is basically an error because we only have one guard. I feel like it's going to be a boring one because it's just simple, straightforward, but you know, there isn't much to say about it. So if you guys want to talk about anything else, feel free to hit me up. I am kind of bored as well, to be honest. I'm getting very bored of this whole like advent of code thing. First of all, because every day you gotta do it, and if you kind of leave it for a day, you're gonna be like, even like apart from being behind for 3 days, you're now gonna have an extra day. So it's kind of shit that I have to do it every day. But we've committed. We're gonna finish it, right? Even if it takes after Christmas to finish it, we're still gonna do it. It is the first year that I'm actually following this. Like I didn't do any advent of codes last year. I think there's only one really, but I did not do it. Even though everyone talked about it, I feel like I've missed the wave a little bit. I should have done it and gained a lot more viewers on YouTube for sure. So yeah. Yeah, so basically, we gotta check if the next cell, next position, is within the bound, right? So that's what we want to do. So if next position dot 0 is more than or equals to 0, conditions. Yeah, we need to kind of get the shape of the matrix here. So shape equals input. What did I call it? Grade. Grade dot shape. And then I do number of rows and columns in here, I guess. So rows calls, that's going to be equals to shape 0 and then shape 1. Simple as that, basically. Ooh. Currently configuring my project so that I have a single CMake lists, which makes a library target from all my sources. One which handles my external dependencies and for my demos. I'm trying to eliminate duplicate code in my CMake files. Yeah, that sounds like a good idea, to be honest. CMake, so let me see if I understand it correctly though. A single CMake lists which makes a library target from all the sources. So you have like it's a add library column there somewhere, I guess, with a bunch of sources set to it. And one which handles all my external dependencies and one for my demos. So I guess you have another target that has all of your dependencies. Is that correct? Doesn't sound too bad. Sounds like a reasonable setup, to be honest. So basically add library, app static, yeah, all sources. Cool, yeah, gotcha. Yeah, so now I can do, if that's more than rows, right, we can actually have a conditions here, I guess, which will be a Boolean list, and I can put all of these conditions. So next position, dot 0. Or in fact, less than rows. And I have the same thing for 1, but we're gonna do it with alls instead. What is the problem here though? Oh, is of course found use size as I32 here and as I. Okay, that makes sense. We got booleans now, and we got to check that they are more than 0 as well, right? So next position dot 0 more than or equals to 0. In fact, we don't even need this. Next position dot 1 is more than or equals to 0 as well. Now it becomes just easy. So range conditions. We can say that if range conditions, not range, god damn it, dot iter dot all if not all of these are satisfied, then we're out of range, basically. Right, let me catch up some target link libraries, app static, public, app external deps. Yeah, that makes sense. Then for the demos, You have target link libraries, demo, private app library. Yeah, that sounds good. That sounds like something I would do, to be honest. Keep it simple. It's very simple indeed. Wait, what is this? Consider the referencing the borrow here. Is there a way to do all without having to pass a closure that just... that literally just returns whatever the values are? Right now I'm linking every demo separately. App external. Right now I'm linking every demo separately. What do you mean you're linking every? You have to link them separately. It's not, you can't do it in the same command. App external demos and interface library. Someone good with Rust help Matt. No, I'm good. It's just an odd one because I have a bunch of conditions in an array here. And I want to make sure that they all are met, right? And usually you do that with the all function. But then I've already got booleans here, so ideally I just want to make sure that they're all true. But obviously to do that I kind of have to put a closure here, which is a lambda that just returns whatever the values are. So it's a little bit of a weird one, really. I mean, I could move this in here. I could do that, I guess. But yeah, whatever. I don't mind it. I don't mind if it's bad code. I'm just gonna say this looks fishy or shady as hell because I don't have interface library for the... wait. What I mean is that I'm linking every external dependency with demo separately because I don't have an interface library for that. Oh, I see what you mean. So your demos are using your external libraries, right? So you're having to link them separately into the demos. But why don't you just do... I mean, I assume they need the external dependency because your actual library uses the external dependencies, right? And they are shared objects or something, I'm going to guess. My question is, why don't you do something like this? So you've got, add library, your static library here. And you also have something like, let me just zoom in for you here. You also have something like, target, link libraries, static lib, public, and then your external, external dependencies here. So that way, when you link your demo, right, to, I guess it would be a private, from your static lib, these will cascade automatically. I'm doing that right now. Okay. Okay, so that's what you're doing. Never mind, yeah. Makes sense. Sorry about that. Yes, dude. As you can probably tell, like I'm half understanding all the messages. My mind is kind of fried. In fact, you guys probably understand exactly where I am today because if you've worked all day and you're doing coding at the end of the day after working all day by coding all day, then there isn't much you can think really, or there isn't much left in your brain to kind of function properly. I'm doing exactly that right now. I just didn't know I could do that before. Okay, right. So looked up some tutorials on how to use CMake. Yeah, so you can cascade dependencies. That's the idea of CMake. So you make everything kind of a target that's fairly self-contained, and if you need any dependencies, you kind of just cascade them through your dependency. It becomes tricky when becomes very tricky actually when your third-party libraries are shared objects, and when you need to kind of like copy the SO files with the executables that you compile. That is something else that you might want to look into in the future. It's called installing. But yeah, I mean, good luck with that. So CMake should do that automatically though for you if you define the targets properly. Oh, I think someone just joined the Discord. Oh, by the way, does anyone know a piece of software I can use to kind of notify when someone subscribes to the channel? Because I don't have like an overlay for subscription, yeah. And I kind of want to get at least like a bell thing. I don't know what the streamers use nowadays, but I feel like we should probably get one as well. Yeah, I'll probably just use static ones. That makes complete sense. In fact, whenever you can, my tip is to just make everything static, because static libraries are much easier to work with than shared objects in C++ or just in general, not in any language, to be honest. There's definitely more hassle involved in working with shared objects or shared libraries. I heard Streamlabs is used, but it's actually a complete rip of OBS. Yeah, I've never really played with Streamlabs. I mean, I could probably give it a search, right? Let's see. Maybe something. So OBS, subscribe, alert. I'm pretty sure there is an alternative. There must be, right? There must be something. OBS does not directly provide streams. However, you can display a set of alert providers, which is then embedded into the stream using a browser source. Animated streams, stream alerts. Wait, what? So literally it's just a browser that people use, because that sounds very interesting. I don't want to pay for anything. I just want something for free if possible. Stream elements. Oh gosh, no, this is too much for me. Like, there's too many animes. Right, let's see. Alerts. Twitch charity. So if I do subscription, or in fact, yeah, sub. I just want something to pop out and say, we got a subscriber. An open source alternative. Pro tip: just write your own in Java. Yeah, I could do. That might be actually quicker. I would have to mess up with the YouTube API though. Maybe we can do that next stream. Let's do that. We'll mess around with the YouTube API. Maybe we can write one in Rust. One that just has a little UI and says, you got a new subscriber. Yeah, let's see this one. New follower. Use element on YouTube. Okay, so you do have to kind of sign up with them. Yeah, that's fine. That's fine. Yeah, next stream, I'm gonna put it down for the ideas here. So next stream, YouTube subscriber alert. I just hope that you can get that kind of information with the YouTube API, because they're a bit, Google's a bit fishy with the YouTube API, so you can't. They only give you like a limited amount of queries every day, so you can't scrape every video out there. So I hope that with the subscriber alert features, you get more of an allowance than you would with the scraping API. That's a good idea. When will you review some viewer code? Good question. So yeah, I mean, I can review it whenever, to be honest. If you've got a good project, just let me know. Problem is that I generally need to look at some code for at least a day before, just so I can get some good comment on it. But I feel like most of the time when people give me code to review is on the stream, which is fine. I don't mind just hopping into someone's GitHub and reviewing the hell out of it. But I'm not going to have any meaningful ideas, because most likely I won't kind of look at the code. I won't read the code. Well, I won't run the code in the stream because it's kind of risky, right? But if I have a day in advance, then I can do it. I sent you mine before. It's in Java and it's pretty old. Can you send me again? Because I don't think I remember, dude. I'm sorry, but is that before I went on holiday for 3 weeks? Is that recently? Because honestly, I don't remember you sending me a Java project. But yeah, of course I can take a look at it, man. Of course. I'm always down to getting free content, right, from the viewers. Why not? So range conditions. So if this is out of range, what do we do here? So we continue. For sure, we're going to have a next position, guard position. Okay, let me see. I know for sure that I kind of want a while loop to like walk until we're out of range. So this is basically going to be the base case for the while loop. These things here. But I don't know what I'm going to do about next position. I guess I'll do it in just one iteration, and then we loopify everything. I just sent you mine before. Okay, you just open your DMs and it's there. Okay, I will do. TGX. Okay, yeah, October 27, dude. Yeah, that was quite a while ago, and I'm sorry that I forgot about it. Pipes games. What is it? It's in Java, right? Yeah. This is what I can see. Spot the Java project. As soon as you open it and then you see like something like this, just nest the directory so you can get to the actual code. What is it? This is a class assignment that was completed on this day at some university for a OOP course. This project's built with Maven. Yeah, we can try it out. I don't mind. We can try it out for sure. After I solve this. Right. Back to stream analytics. Okay, we got analytics again. Yeah. So the idea is if the next cell is a wall, we have to rotate the guard, right? So we kind of do something like, next guard or new there. It's going to be rotate guard. And then we have, what do we have? Guard direction. Is that right? Yeah, guard direction. Yeah, we're going to have guard direction here. And then... Okay, that should work, right? Yeah, that should work. So we rotate the guard direction. And then for the current position, we're going to set it. Need to update the guard position without rotating. Oh, no, yeah. We need to update the guard direction without rotating. That's what we need to do. That code is 1.5 years old, so it's probably horrible, but got 100% on it. So it can't be horrible. If you got 100% on that piece of code from a very old university professor that probably can't read code, then it's probably okay. It's probably okay. Unless he's one of those that's looking for overly optimized code that is pretty much unreadable, then maybe not. Maybe it is bad. I don't know. So we do that, and then... Yeah. So if we have visited or unvisited, we simply do... Now this is where we update. So we do grid next position. Right? Yeah, next position 0, the next position. Which I have to turn these into usize. The next position is going to be our guard currently. I guess it's going to be guard cell, right? So guard cell, guard row. What is it? What do we call it? What did we call it? Guardinum. Yeah, and the previous one. So where the guard is, I guess, the guard row. And guard call, I guess. That's going to be visited. So cell visited. That's basically it that we do here. Yeah, beautiful. Beautiful, beautiful, beautiful. So we turn around. Now the thing is, I don't understand if in the same iteration, it doesn't matter if it's in the same iteration or not. Yeah, so we're gonna be while looping all of this. What output are you looking for? And MYIs, I hurting seeing this masterpiece. What do you mean? You talking about my code or GTX? Because dude, I don't know. This is definitely a masterpiece, yeah. It's probably very, very bad Rust code for sure. But welcome to the stream, ZK. Hope you enjoy it. Don't forget to drop a like because it does help me out quite a lot. And I hope you can help me solve day 6 of Advent of Code in Rust. Yeah, so the result here, grid walk, we can just return it at the end, I guess. Right? Maybe not. Okay, we got anyhow the result. We got a bail here, which should have been something like this cell could be a guard. Because we kind of already checked it before here with this. I'm getting ready to be embarrassed. I'll take a look at it together with you guys. I'm just trying to quickly solve this. Right. Right. So the guardian, so this is where we find the cell. What I really want to do is something like, while until we've walked, like, so until range conditions. I guess this is where I can put the range conditions thing in here. I don't like this. This is what I don't like. This line here. I just want to make sure that all the values in here are true. That's all. I guess fold could do, but then it's worse than all, isn't it? So while range conditions and all of them are there, we keep walking, right? That's what we're going to do. We do all of this. So we do a select cell grid next position. We probably should put this guy in here. Ooh, no, because we need the exposition in there. Wait a second. Where's next position? Next position is here. I guess muted is. I guess muted is. So let me see. Next position should always... Yeah, I mean, I'm going to have to repeat this bit of logic at the end. Because I want to move every time, right? So I kind of want to do... range conditions in here. Now let me think. What am I trying to do? So I'm trying to move... I'm trying to calculate this in every iteration because I'm going to be moving until we go out of the grid, right? So I'm kind of doing a walk. Let's see if we can get the... Oh, did I close the wrong tab? I did. God's sake. Advent of Code. Advent of Code. We're on 6 again. So I'm starting in here. And I'm kind of just walking until we reach an out of bound index, right? Because that means the guard went out of bounds. And that's how you terminate all of it. So I need to calculate these range conditions every time. But I also need it to be available on the first one, on the first iteration. But I can just probably do it here, to be honest. Okay, let's just do that for now. Okay, that's a little bit better. What's the problem here, though? Mismatched types. Expected bool found. Bool. What? Okay. What? What the hell? Consider removing the borrow. Oh, yeah, yeah. Yeah, never mind. This is what we have. So I can at least calculate all of that. And next position has to be kind of done here. And it's mutable because I'm going to move every time. What is the problem here, though? Let expressions are not supported here. Is that better? Yeah. And now I can bring everything else in here, for sure. So the next cell we have in the next position. I'm going to say that the next position is the update. The guard position at the end. And everything else can be brought. Okay, now we have something that may work. Something that may work, but we don't know. That is great. So let me just make sure that I have exactly what was supposed to be here. Right, so let's pseudo run this algorithm in our heads. Okay, so we initially find where the guard is. So initially find, let's see if I can bring it up. In fact, can I have a screenshot of this and then put it always on top? There you go. So that I may be able to do it always on top. There. Whoa. Yeah, so we basically initially find where the guard is, which is this. Oh my god, this is way too thick. Down the line thick. We find where the guard is, and then we check the next position, which is this one here. In this case, it's a wall, so we're not going to move the guard, we're just going to rotate it, so it's facing that way now. And then we go to the next iteration. Next iteration, we do the same thing. So we have the position of the guard, and then we check that. And if it's an invisitor thing, we move the guard there. So the guard is no longer going to be here. That's going to be a dot, and this is going to be that. And this is actually going to be a visited like macro, so the X. And we do the same thing. So that's going to be turned into that. We're going to move there. And then we're going to turn into an X here. And that's going to be moved there. Up until there, where we rotate it again. And we keep going until the thing is out of bounds. So that's the idea. But I'm not sure if it'll work. I'm getting ready to be embarrassed. That's what she said. I don't know which bit of the speech there was that's what she said joke, but I understand. The line thick. Yeah, that's the one, right? But that's the idea. So is it going to work? Probably not. We have next position in here being initially where the guard is supposed to be. I think we only update it really in here, right? This is what we want. We don't update it if it's a wall. So we just rotate the guard, and that is it. That is exactly what we do. But if it is a visited or unvisited cell, then where the guard is currently gets a visited, and the next position is the guard enum. That is it, right? And obviously we say that the next position is then the guard current position plus the direction. That's thick. Yeah, thank you. I love That's What She Said jokes. And I think that's it. I think this should pretty much do it. I'm not too sure. I mean, I'm not going to talk about how we kind of do the rotation. It's very easy. Rotation matrix there. And this is it. Should we see if this works? Let's see. I'm going to do my try main thing again because I love it. Okay. Okay. So we got a try main function here that handles the errors, and then the main actually does the error handling. That is. What we firstly need to do is we have the test thing in here, right? So what I want to do is I want to try and read that, I guess. So include, oh, here we go, Bitdefender again. Once again, figuring out that I've got OBS open and it's shooting its shot is just getting free advertisement for you guys, or for me. I hate that. I hate that. Absolutely hate Bitdefender. Channel sponsor time. Yeah, no, we are not sponsored by Bitdefender. Don't buy Bitdefender. Get it for free. You know, in fact, torrent it because they're getting free advertisement. I don't like it. Day6 test.in, and that's going to be my input string. I forgot a let in there. It's not C++. Okay, now I need to do a what do we call it? So grid. Yeah, let the grid is into matrix, I guess, and that turns into a thing of cell. Yeah. So input string. What is OK? OK is a monad in Rust, so it's a result, right? So do you know std expected in C++ is the same thing? That's where C++ expected comes from. It's from result in Rust. So it's either an OK value. So here, so result is either an OK value with something inside it, so an actual value inside it. Think of it as an optional that's got a value in it, or it's an error with an error message, kind of like that, right? That's why you can see it. And it's a nice way of doing error handling in Rust because you embed the error into the return type, and I absolutely love it. I absolutely love result in Rust. And in fact, it's not result that I'm looking for, it's anyhow result, which is a different result type that plays nicer. Ooh, but isn't that extra overhead? No, is no extra overhead. It's just all the values are on the stack. There's maybe like an extra few bytes overhead, but I think it's fine. It's better than doing like a pointer and a boolean to make sure if it's like a valid result or something. Anyway, so we've got the result matrix there, which is going to turn into that. We're going to use that question mark. And now, this is where we do grid walk. Right? Grid walk, that's the one. And we are going to take the mute as grid. That is it. Oh, no. That was right. Cannot mutate immutable grid. Okay, because we need to put it as mutable. Okay. Did it work? Print line. Now, can we print grid? That is my point. Can we print grid here? I don't think it will let us because it doesn't have a display on it, right? So we need to implement display, which means that we should implement display on these types. Okay, just import display from FMT, please. God's sake. You are smarter than that, LSB. Now, why isn't that displaying? Cannot find the right macro display in this scope. Wait, what? What am I not doing right? Derive display in Rust. So FMT display, yes, std FMT display for structure. So does it not have a derive on it? Import display. Wait, can we derive display in Rust? Is that something that has a default thingy? Well, anyway, we don't need display, right? We just need debug here. Because if we have debug, then we can have this, which is just gonna show all the members. Why did I do all of this? I just want to check that it's actually working. So we're gonna run it. We're gonna run and see. Right? So it didn't work because something found a second guide on the board. So we found a second guide on the board. So basically we ended up here. That's interesting. So let's see why. So the next cell is a guard. And the next position, his SOP coming up with a Polish again. Hello, dude. How's it going? So why is the next position here? So 4 and 5, right? So we are 4 and 5. In other words, the 6th per row and the 5th. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Apparently we're supposed to be here. So the next position is there. Which is correct, right? Because we want to go up. So maybe there is a... okay, wait. Next position. No, not okay. So where's the guard position? Let's try that again. What is that emoji? It's a speakers. It's a megaphone, right? That's what it's called. Is it? It's the sad megaphone. Right, so why is that not working? So the guard row is in 6, guard column is in 4. Is that correct? So 6 and 4, which is correct. Yeah, so we are in the right place. And next cell somehow ended up being a guard. Why? Oh, it's because we never update the guard row and guard column. Okay, that makes sense. That makes sense. Next position is that, and then guard row and guard column. I mean, the only way we can do this is by doing a mute here and a mute there. And in here, I can say guard row and guard column. It's going to be equals to next position. So 0. And if I can do this properly, next position dot 1. Right, that's it. Mismatch found you 32. So what type is this? That was usize. No problem. No problem. There you go. Let's see if this works now. I suspect something else will break, but it is what it is. And we're going on forever. We have an infinite loop somewhere. So we rotate the guard. So we rotate the guard. Maybe we did want to update it anyway. Maybe we want to do this anyway, right? Rotate the guard, and we take the next position to be the guard direction. Guard direction, okay, yeah. Good. Let's see if that works. At this point, it's just trial and error here. I've got the basic of the algorithm, but I don't know if it's always going to work. Okay. This is kind of looking fine, I guess, right? This is kind of looking fine. Now, what happens if I just print the number of visited things, right? So, part 1 visited. I'm expecting, is it 47? What is it? 41 different visitor things, right? So we have the grid here. Grid.iter. Let's see. Yeah, iter will do. So iter is available there. Dot map. Cell and cell. In fact, we just want to filter, right? So filter all the cells that have that are visited, for sure. Okay, let's try that now. No, it's 40. It's 40. Why is it 40? It's off by 1. So could it be that the last one is not getting counted? I think it might be. I think it might be. Yeah, you see? The last one is not getting counted. Again, look. It's happening again. Bitdefender is just taking the piss now. And it's making me annoyed. It's making me annoyed. Yeah, so the last one. So what we do is, like, we have to set grid. I guess wherever the guard is, right? Last. This is where the guard is. Guard row as usize. Oh, guard row and guard column. Guard row and guard column. That's going to be equals to cell visited. Righty. You already going, Sopu? Yes. That is sad, yeah. That is sad. Today's not a good day to hang out, I guess. Should have left the stream for another day. Visit 41. Okay, that's better. So that means I can actually copy the input now and get the right answer. All right, boys. Here we go. So we're going to add a new file. And we're just going to compile the code with day6.input instead. And we're going to run it. And we're going to run and hope that it still works, right? There you go. So it still kind of works. 4776 is the one. This has been one of the easiest ones, if it works. Is it 4776 or 4776? Yeah. Yeah, this has been one of the easiest ones I've done so far. Now, I guess this is where it's about to get hard. No Java, no viewer, so I'm going to read a book. Yeah, fair enough. Yeah, dude, go read. Reading is better than watching me, for sure. Get that knowledge. Knowledge is power. If you get that knowledge, you're going to have 2 Ferraris in your garage, here in your garage. That's how you get the Ferraris. While the historians begin working around the guard's patrol route, you borrow their fancy device and step outside the lab. From the safety of a supply closet, you'll time travel through the last few months. I hate these backstories. I'm multitasking right now, writing CMake script. Yeah, dude, as you should. Fortunately, they are pretty sure that adding a single new obstruction won't cause a time paradox. They like to place the new obstruction in such a way that the guard will get stuck in a loop, making the rest of the lab safe to search. Okay. To have the lowest chance of creating a time paradox, the historians would like to know all of the possible positions for such an obstruction. The new obstruction can be placed at a guard starting position. The guard is there right now and would notice. In the example, there are only 6 different positions where a new obstruction would cause the guard to get stuck in a loop. The diagrams of these 6 situations use 0 mark to mark the new obstructions, this to mark a position where the guard moves up and down, this to mark a position where the guard moves right and left. What? So if I add a new obstruction in there, okay, so this is where the guard will be moving. Right, this is going to be difficult because we want to coding with my. You forgot about my bad Java code. I haven't forgotten it yet, dude. I'm still so. It's the same problem. I'm gonna try and review it as soon as we finish this exercise. This is a different problem here. This is a weird problem because we have to detect an infinite loop in my code. And you know what happens when you try and detect an infinite loop in the code? That's called the halting problem, for those who don't know. And it's one of the problems in computing that are quite difficult to solve because they're kind of impossible, I think, right? Detecting a loop. So option 2, put a stack of failed soup prototypes in the bottom right. Option 3. Wait, what? I don't understand. This is getting too complicated. It doesn't really matter what you choose to use as an obstacle, as long as you and the historians can put it into position without the guard noticing. The important thing is having enough options that you can find one that minimizes the time paradox. In this example, there are 6 different positions you could choose. You need to get the guard stuck in a loop by adding a single new obstruction. How many different positions could you choose for its obstruction? This is difficult. This just turned into the hardest problem still, like, or yet. So to be honest, I don't completely understand what they're trying to do here. So they are trying to add a single obstruction that will cause the guard to enter a loop, right? Option 2 is put a stack of failed soup prototypes in the bottom right. Yeah, so they will be in a loop here. Right, yeah. Option 3, put a crate of chimney squeezed prototype fabric next to the standing desk. Option 4, put an alchemical retrocabulator. I don't even know what this is. Like, what is this word? What the hell is that? Ask Copilot. Let's go, Copilot. What is this? The retrocabulator is a fictional device often used in humorous technical jargon. The term was popularized by a satirical video created by Chrysler in the 70s, which featured a mock technical explanation filled with nonsensical jargon. The video has since become a classic example of engineering humor. Okay, I guess I'm not an engineer. I don't understand that. Anyway. Yeah, so you're supposed to put a single obstruction somewhere. It doesn't really matter what you choose to use as an obstacle, so long as you and the historians can put it in a position without the guard noticing. The important thing is having enough options that you can find one that minimizes the time paradox. In this example, there are 6 different positions you could choose. You need to get the guard stuck in the loop by adding a single new obstruction. How many different positions could you choose for this obstruction? So you're supposed to just coding Rust is mental disorders. No, dude. No, dude. It is not. It's sign of abstraction and fanciness, if that's a word. What was that come down with me phrase again? Grace and decorum. That's what Rust is. It's a sign of grace and decorum. How many different positions could you choose? So they just want us to get the number of different positions that would generate a, I guess, yeah, I guess a what do you call it? An infinite loop, right? If you're coding Rust, would you consider a language like C++ for mental disorders? Hello, me, Patrick. Welcome to the stream. I mean, would you consider Java a problematic language? Because I would. You should definitely see a psychiatrist if you code in Java. I'm just thinking about how we can solve this. I guess every one that we visit, yeah, every cell that we visit, we can record the direction that has been visited with, right? Tell you what, yeah, we can do that. Because if we visit the same position twice, going in the same direction, that means we're stuck in a loop, right? Yeah, that means we're stuck in a loop because of the rules of the game. So I guess that's what we can do here. That's one of them, right? So like if we go in this direction here and we reached this cell going upwards for the second time, we are in a loop because we're going to end up here again. That's what this means. So in this case, it's not quite the halting problem because there are heuristics that will help us. But yeah. What is the change that I need to make in my code here? Well, visited has to take a vector of positions, I guess. Vector of I32 and I32. That's it. Now, a bunch of places will fail. And yeah. And this is where we can split these two things. So now we can have a cell of visited, which is a this directions. And we remove that from here. Now instead of doing this, we need to add to the existing directions. If it wasn't visited, we're now going to have visited here, which means we can just put a vector with the current direction, right? So which is the guard direction. That'll be it. Okay. If it's already visited, this is the interesting thing. We have detected a loop, right? We have detected a loop only if the current direction is already in the set. In fact, let's change that to a set here. So hash set Hash sets are always the answer to anything. You don't know what algorithm you need? Just use a hash set. My dudes, just use a hash set. So the copy trait cannot be implemented for this type. This field does not implement. Wait, what field? Please don't tell me. By adding a hash set, I'm gonna mess up my my things in here. Just use Java. I could just use Java. Or in fact, I'm just gonna keep it as a vector. Wait, I can't even implement copy for that. That's fine. Now something else will fail for sure. There you go. I think Rust is mostly a simpler C++. I don't see how someone can see Rust as bad and C++ as good. STD in order to get to. Yeah, that's right. I think I agree there, Patrick. I don't think it's simpler though. I think it's actually more complicated because you have a huger or a bigger standard library, to be honest. And there are, more concepts in Rust than in C++. If you want to learn about the borrow checker and traits, these things do differ in Rust than other languages. But it does have a bunch of things that helps us. So you can make Rust code very simple by just using the standard library. And, staying out of like raw loops and stuff like that. And just use like iterators instead. Those tend to help the readability of the code quite a lot, in my opinion. But I wouldn't say it's a simpler overall. I think it's it's definitely a more complex language than C++ for sure. Rust is harder for beginners, but if you know it well, it might be much easier to do some things. Yeah, for sure. You have less things you have to implement in Rust than compared to C++. In C++, you have to implement a string split in C++. Think about that. That's, that by itself is already a turn off for some people. But yeah. So we have only if the current. Okay, so we have this here. So if this dot contains the current, the guardia, right? If that contains the guardia, loop. We have a loop here. And we have to return a loop. So what I'm going to do is I'm going to walk on the grid in every single direction and add an obstruction. Yeah. I'm going to add an obstruction to every single possible position and detect when it contains a loop. That's all. I'm going to create an enum here for the run type. Normal or loop. And we're going to go to line 65 here. And return a run type. That's all. We got normal here, and then we are going to return okay loop. Smart pointers are confusing. Move semantics can be confusing. Rule of 5 is confusing. Errors are confusing. C++ takes a lot of effort to master. Yeah, I agree. But then so does Rust. Rust has that and a lot more. Rust has every single one of those topics. So it has move semantics with the borrow checker and stuff. It has cloning, copying, the traits that you have to implement. Rule of 5, not so much because we don't have OOP in there, I guess. But yeah, there's even more stuff than that in Rust. So I think they are equally difficult languages if you want to master. In fact, any language is difficult if you truly want to master something. Python is difficult if you truly want to master it. I wouldn't say that I am an expert in Python. I know Python quite well, but I don't know all the ins and outs of the language. What I will say is that I like Rust over C++. Well, I wouldn't say I like Rust over C++ overall, but in certain scenarios, the compiler gives you a lot more help than C++, right? In fact, in most scenarios, unless you hit a case in Rust compilation where a nice error message hasn't been developed for it yet. So if you hit those, you will know, because your error messages will be massive and you won't be able to understand what the Rust compiler is saying to you. But in most cases, the Rust compiler is actually way more helpful than the C++ compiler in terms of telling you, how to get something to compile. I would agree. I would argue it's not. Even building C++ is pretty hard to understand. Yeah, I mean, with that I agree. Building C++ is hard to get going, right? It's not hard to understand. It's the same logic as building Rust. You need a compiler. You need a compiler for your particular platform. You need to set a target for the compilation. The thing with Rust is that it has like an ecosystem that is part of the language, right? So it has a build system bundled with it, which is Cargo. In C++, you don't have that, so you kind of have to learn it, which is kind of, it's kind of a turn-off for people. For networking, I enjoy my time away more in Rust. For game dev, I completely understand. Yeah, I would agree with that as well. Game dev is definitely, C++ heavy. I wouldn't necessarily do game dev in Rust. Not if you want to get a job in it, for sure. I'm doing game physics engine dev in C++. I wouldn't switch to anything else. Yeah, and the thing is, you shouldn't really, because most of the tech for games is in C++, right? Unless you're coding a game in Unity, in which case you can do C#. But from what I understand, from my time of working in games, C++ is the kind of like the master language for games. Rust is fun. Put it that way. If you're doing a game in Rust, you're doing it for the fun, not for the kind of ease of use there. Basics of C++ looks like Java. However, Rust, you have to care about borrowing or ownership from the start of learning. Yeah, you do, and these concepts are hard to understand, is my point, because they're not in any other language that I know of, for sure. So that's what makes Rust a little bit difficult to get into if you come from a traditional language background. Geometry libraries are in C++. Linear algebra libraries are in either C or C++, yeah. But I know a lot of people that build infra AWS are scared to touch the C++ code, while they don't mind the Rust code as much. Yeah, and it goes back to the point that with Rust, you have a build system. You have a build system bundled in the language that has really, really good documentation, and things are just easy to use. But with C++, you don't have that. If your infrastructure people are having to suddenly take care of a C++ project that has CMake, that has Clang 17 in it, and a bunch of other tools in the build system to help with building and code quality, they have a lot more to learn than just having to kind of build a Rust project and call Cargo Clippy. That's already part of the installation anyway. So that's it from my perspective. When I talk to DevOps people and they talk about C++, they're usually scared because of that aspect. Like they have to understand a lot more, and it's not just one language, it's not just one tool, than they would with other languages. And yeah, in my opinion, that's what kind of differentiates good DevOps engineers to bad DevOps engineers, right? So good DevOps engineers are kind of like not scared of learning, CMake, and learning how a C++ package manager works, and the differences between the compilers, and which compiler you should use for a particular platform. Clang, that is, always use Clang. Do not use GCC anymore. GCC is outdated, guys. Do not use GCC. I know Google has an OS called Fuchsia, which they built a security stack for it using the type system. They modeled deadlocks, and after 5 years of development and 6 months of tests, they modeled deadlocks, and after 5 years of development and 6 months of testing, they had found only 3 bugs, and that's with 100 plus mutexes. That's an incredible feat, to be honest. I mean, I introduced 1 mutex in my code, and my computer just blue screens. Put it that way. I do not like working with with multi-threading. But they must be doing it in a type safe way, right? So what language are they using for that? Because I'm gonna guess it's like either C++ with heavy use of like sanitizers or something like that, or something like Rust or Zig, or something a little bit more modern. Of course, we do simple things, and C++ looks more like C with classes, but it's just easy then. Rust. Okay, yeah. Yeah, that makes sense. So Rust has all of these tools, all of, thread sanitizers and address sanitizers built into the compiler, and it will tell you off if you do something wrong. There are cases you can get bugs in it, but in most cases it works fine. For you to get that same functionality in C++, you need to know how to kind of enable sanitizers. You need to know how to run like fuzzing or your unit test or whatever with sanitizer enabled. You need to run asan. You need to run all of that, Valgrind and stuff. And it's just a pain, really. I mean, that's what kind of turns people off in C++, in my opinion, is the ease of use for sure. But at the same time, yeah, I don't mind it. I like C++. It was my first language, to be honest, and it's the one that I keep doing every time, and I don't think I'll ever stop doing it unless I can't get a job in it anymore. But yeah, and I also do Rust at work every now and then. So yeah, I used to do a lot more Rust though. But who the fuck writes unit tests? It's a waste of time. Yeah, tell that to I guess any production software engineer ever. So okay, so this is a loop here. So visited. How many could you choose for this deduction? Yeah. If it's unvisited, if it's visited and it contains, else we are simply going to add this, the. Can I match mutable? Oh. That mean mutable? Yeah, that can be mutable, right? So there's the insert the current direction. So the guard. Okay, yeah, good. The cool thing about Rust is that you can have smart people write the unsafe code. Yeah, those smart people can do formal checking using formal checking software, and then everyone benefits. This is how you get type safe byte casting with libraries like bytemuck or zero copy. Check the memes. I'll send you a meme for you. Something about testing. Let's see. It better be not be racist, dude. You've been sending too many questionable things recently. We do not test on animals, we test in production. Yeah. I like that one. I like that one. That's kind of wholesome. That is very wholesome. Right. Okay. And then self-visited. So grid self-visited. Guard direction. Right? Why is guard direction not working? Found the reference. Okay. Yeah, okay. Hash set that dot from. Okay, boom. Here we go. So why is this not working? Cannot mutate immutable value directions. Okay, so how do I? Okay, so borrow mute is the one. Consider borrowing here. Wait, now I'm getting all sorts of random shit in here. Use of moved value in here. So guard enum. When was it moved before? Okay, just clone it. Just clone it. Can I borrow this as mutable as is behind a something reference? Does that work? Wait, how do I match something to a mutable type? So basically, Rust mutable match arm. How to borrow mutable reference during a match? That is a good question. That is a good question. Match d.get mute unwrap. Ah, okay. So what I do is do that, I guess. Does that work? No. So get mute unwrap. Any this ref and mute ref pairs can be omitted with compiler inferring them. This is slightly optimistic explanation, but it's the essence of it. If I leave it without that, we have this. I want this to be mutable in here. Rust match mutable inner element, I guess. So do I have to do this? Does that work? No. Oh gosh, come on. Ref mute. So I have to put ref mute in here? I have no idea what ref mute is. I mean, I know mutable is mutable, but what is ref and where does it come from? Never used it before. Can I borrow data in this as reference? Can I borrow? Okay. Why not? Why not, you stupid bastard? Oh. Can I borrow as mutable? In a this reference as a mutable. Mismatch types. Expected reference cell found mutable reference. Mute is expression as type cell. Ref matches enum inner value as reference. Thank you. We cannot borrow next cell 0 as mutable as it's behind. What? Does that work? No. Cannot borrow data in a reference as mutable. But this is a... Oh, hold on a second. Yeah, I get it. That is... Okay. Does that work? There you go. I should probably get rid of this one here as well. Right? Or maybe not. Oh, no, that doesn't work either. Kind of move out of movable. This is where the borrow checker absolutely destroyed my life. I will say a year ago you had people who kind of put Rust on a pedestal, maybe a bit too much. This has kind of settled down now. And I mostly hear what I mostly hear is people complaining about the Rust fanboys. Yeah. I think it's because of the well, kind of completely blown out proportion videos that we've seen in the last few months where someone's giving out a Rust talk and then they start fighting for some odd reason with Linux kernel developers. But yeah, if lets you use match variables after the match block, if it lets you use moving it from self-visited ref matches. Sorry, Sop, I did not get your suggestion. I'm trying to figure out what the hell I need to do here. Let mute. Okay, yeah, there you go. That's all. Can I remove this one though? This is not going to compile, right? This is for sure not going to compile, right? There you go. I knew there was something wrong. I just didn't scroll. So kind of move out of shared reference. Move occurs because guardianum has type cell, which does not implement that. Matches that. Dot. Clone. To own, is that a thing? Option. So this is going to give me an option of usize cell. But we can't move it out. Next cell is still usable after the match statement. Thanks for matching it with ref keyword. You borrow the inner value of the next cell instead of moving it. Ah, interesting. Come on. Come on. So kind of move out. Data is moved here, line 67. Move occurs because guard enum has type cell, which does not implement the copy trait. Yeah, so it's because we had copy over here. We no longer have that. So find, if it matches that, we're going to find it. So what if I map it to, what is that? So clone works, right? So clone, does clone work? No. Yeah, clone is something I've got here. I don't know why they can't just implement enum type this instead of ref syntax. Yeah, me too. It sounds like it sounds like that ref keyword is there for this specific reason. And there's got to be something in the compiler that's not letting them implement that for sure. It's got to be some like really final boss like bug that they introduce if they do that. Rust just being Rust. Yeah, maybe. There'll be like technical reasons for why they don't do that though, for sure. I can just tell. Right, so this doesn't work. What am I meant to do here? So intuiter, index iterator, find this. What if I just found it and not? Mismatched. Expected option. This. Okay. So I'm not sure where the problem is. I think maybe because guardianum has type cell, which does not implement. So guardianum, this one here, does not implement the copy trade. And what was the reason why we couldn't do it anyway? Because of the hash set, of course. So because of the hash set, we cannot copy it. Just clone the guard. Yeah, that is a good. It's a good point, right? Run type. I can go as well. It's a good point. I just kind of wanted to understand why I wasn't able to do. Oh, rotate guard. What's going on here? So what is guard dir in this case? Okay. Little by little, I'm getting rid of everything. They make syntax compiler devs friendly instead of Rust user friendly. Maybe. Cannot borrow grid as mutable because it's also borrowed as mutable because it's also borrowed as immutable. Immutable borrow occurs here. Now why the hell is this actually red now? Data moved here. Type cell does not implement. Okay. I'm gonna clone everything. AB. I don't need those, but I do need to have pseudo clone for sure. Right? Is that a little bit better now? No, didn't like that. But it kind of makes sense. We don't have to wait 5 years until compilers developers implement a feature like in C++. Year 2077 breaking news. Clang just added full support for C++ 20. Yeah, that's a good meme. That I'll give you that. Okay, I think that's a little bit better. Not ideal because I've got like a bunch of like random shit, clones and whatnot happening for no reason. But this will do. Now, cell visited is one of them, right? So cell visited is there. Does it still work is my question. And will it compile? It will. It seems to be compiling. But we have way less. Ah, okay. So we need either that or matches. Oh gosh. Or matches. C cell. No, so it has to be visited, right? Yeah. It has to be visited for sure. Am I getting this? Why do I only have 111, 190 something now? Instead of like 2000 or whatever. However many positions we had before. That is fishy. That shouldn't have happened. I just did a basic refactoring. Ah. So I do get somehow into this pickle here. If it contains the guard difference, this in this case. Oh, I can't see it, of course. Amazing. And guard there is also not visible for some odd reason. Why can't I see the value of guard there? There you go. Beautiful. So we've already gone through a particular cell that's already visited in the same direction. So we detect a loop, which is not right. Wait, what? That shouldn't have a loop at all. If it contains that, you can see it in the variables window. Yeah, that's true. I could have used that as well. So Deers is not gonna. I want to see what Deers is. And why in hell we're getting this? Because we should be going into that every time. So it's actually on the second one. So it happens very, very early, in fact. Damn it. Damn it, damn it. Have I messed up a... No, I didn't mess up the match. So we should find like so many of these. Yeah, should be a lot of them. And then we find something that we already visited. And then in the second one, this is fishy. Wait, let me see that again. Ah, I see, I see. It's because we forget to update the guard. That's why. We should do the same thing here, basically. This is what we should be doing. Found the second guard on the board. Jesus. Oh yeah. We forgot to update the guard as well. See, I don't like this. This could be refactored into a function with a better name. Like update guard or something like that. Or walk the guard. Okay. Now. Okay, yeah, good. Good. That's better. That's what I actually expected. So we basically have the whole solution now. So the remaining thing is to go for each position, make sure that we can, I guess, like we add in obstruction somewhere and see if there is a loop. Oh, that is something I didn't understand though. So is the challenge? Good night, Sop. Is the challenge meant to add an obstruction at the start of it, or after the guard has already started running? Because that would be annoying, to be honest. That would be incredibly annoying. Because you could run and then add one just where the guard was, right? So fortunately, they are pretty sure adding a single new obstruction won't cause time paradox. They like to place a new obstruction in such a way that the guards will be stuck in a loop. To have the lowest chance of creating a time paradox, the historians would like to know all the positions of the possible. Let's know all of the possible positions for such an obstruction. The new obstruction can be placed at the guard's starting position. The guard is there right now and would notice it. In the above example, there are only 6 different positions where a new guard obstruction would cause the guard to get stuck in the loop. Diagrams of the 6 situations use 0 to mark the new obstruction. Okay. It doesn't say that they put the obstruction at the start, I guess. But yeah, you put the obstruction before the guard moves. Yeah, thank you. I was just making sure because if it was after, we would have a real problem. But now it's easy. I mean, we just gotta use some iter tools here. So cd day 6. Gotta go add iter tools. I'm gonna cheat a little bit here because what I'm gonna do is I'm gonna find where the initial guard is. And I'm just gonna hard code that because I can't be bothered like finding the guard position again. Okay, so they are in they are in 95 and 68, right? So 95, 68 is for the 95, 68. Just to make sure that is the case, right? So 95 and 68, yeah. Okay, so what we do is look at the shape of the matrix of the grid. We get the rows and the columns. as usize, okay, and then we do for, I guess what we can do is 0 to rows dot Cartesian product to 0 to calls dot retain iter. Is retain a thing? No, retain is not a thing. I'm gonna just very lazily do a filter here. To remove that thing, right? So the there you go. So I'm just gonna do this. So if I guess row and column. What's the problem here? Okay. I mean, I could have also done this, I guess. Yeah, just gonna filter the ones that aren't the initial column. And then we're gonna map everything to, now this is the interesting thing, right? We're gonna map all of the positions. So row and column. Wait, why is the filter receiving a 932 here? And now I'm receiving a U size. That is interesting. I'm going to map all of them into a guide walk, right? Where the grid has been slightly changed to include an obstruction at the start. Now, how do I do that? I guess it would be better if I do a for loop, because I don't want to create like a map full of these things in it. Wait, what? Wait, what's the original? What's the length? What's the actual type here? Oh, okay, so it's a row and column there. That's better. Yes, what I can do is I can basically the original grid here. I'm gonna clone it there. We're gonna do it again here. And a new grid, and then we have R and C here, which are both U sizes, right? Yeah. That's gonna be a cell dot wall. Okay. And what do we have here? We have a mute. I was gonna keep track of how many new cells with an obstruction in a particular new position will end up in a loop. That's all. That's all I'm doing here. It's nothing too difficult. Okay, so now we do, I guess, grid. Is it grid walk? Guard walk, that's the one. Mute, new grid. So I want to see if this, if let, I guess. Yeah, so if it ends up in a loop here, we're gonna increase the count. What? It's assigned to but never used. Okay, yeah, it is assigned to but never used. So now we do a print line saying part 2, and this is the number of loops that we end up with. Right. Is this going to work? I don't know. We're just going to run it and see. How we do that? I'm actually quite invested now. Part 1 visited. Remove that. Remove that. It's definitely taking some time to do all of them. I feel like we haven't captured any of the infinite loops now. You see? There's. So we are in an infinite loop somewhere, but we somehow are not ending up here. So what is this? I can't see this again. Jesus. Yeah, so it doesn't catch any of the loops, which is annoying. But why not? Why not? So we have the grid, the guard position, right? Yeah, so we only rotate the guard in here. And we get a next position at the end for all of them. We are clearly in an infinite loop here. I wish I could see what the this is. Should I do that? I'm just going to put a print line here. Our position X and Y, what do we have here? So we are a next position. And then we have guard position. This doesn't implement. Wait, what? Okay, that is fine. Just sod it. See, there is this one here. Oh, we are getting some of them. We are getting some loops. If we just let it run, what happens? Are we still finding them? Now, this is where we actually end up, we don't detect the loop. So let's see what's going on. So revisiting 18 and 18, right? So This is very, very upsetting. This is definitely just going on and going on, right? Yeah, because these indices are repeating quite a lot. So we are at 718, going down 1. Also going forward, going backwards 1. Going backwards 1, down to 709. Then we rotate. So this is wrong. How is it rotating from -1 to 1 there? This is what I don't get. It should be rotating 90 degrees. What's your criteria for loop detection? So the criteria for loop detection is visiting the same cell, going in the same direction as you previously did, because that detects a loop. So that is my criteria here. That is interesting. Yeah, so I would expect going backwards to go to -1, 0. Not this, for sure. Let's see when they turn. So the guard is there. So they rotate twice. That's what happens here. So the guard is now... Where is it? At 7, 121. Wherever that is. And then we rotate him. Rotate the guard. The guard should still be at 7, 121, right? But now we kind of rotate him again, going backwards. So, yeah, it's just going up and down. They're just going up and down here, and this is not being detected, which is interesting because the directions should be saved in here, in this case. But it's going in here. So we do insert a direction, the guard direction. And go to the next one. But I would expect this one to be hit as well when it turns around. So there, this is where I would expect this branch to hit. Because we are now going back. The cell is visited. And that hash set should already have something in there. Maybe let me print that. Let me print. So print line hash set. Because clearly something wrong in the logic is going on here. Okay, let's not rotate the guard. Let's just let it go. Okay. Let it go until we reach that stage where we have back and forth for a bit. I think we have reached it. There you go. Oh no, we haven't. There you are. Okay, now we have, right? And this will reach once, twice, once, twice. See, we're going back and forth between those. Hash set is only... So for example, 716 has been visited. just now, going in the direction 0, -1, right? So the hash set for what? What are we? So the next cell is 715. So 716. See, and that only has one direction, not two of them. Do you save your position before rotating? Good question. I should do. I think I do. So the idea is to get a next cell. First thing I do is get the next cell that we would get if we walked one step ahead with the guard. And then I check that next cell to see if it's a wall, a visited or unvisited cell. It couldn't be a guard, so you just throw an error there. I don't save the position. What I do save is the direction I was going in when that cell was visited. Because obviously, you're in the cell, so you don't have to save the position. You know what the position is. But this line here, see, so 119 is got 0, 1 there. $119 now has 0, -1. Now 119 has 0, 1. So the hash set is somehow like losing the values. What am I doing here? So there's definitely some like cloning thing that I'm not doing properly. So insert seems to me like it's okay. Ah, this is the reason. You see, this is the reason here. So cell the guard row. See, this is creating a new set all the time. But maybe you'll never. I'm just replacing them. That's the point. So unvisited makes sense to do that. Not visited. So grid, cell visited. This does not make sense here. Gosh. God damn it. Now let's just run this and see what happens. Found a second guard in the board. Right, so now it's a little bit worse because we're finding a second guard on the board. Ah, yes. So instead of this, we need to have something else, right? So in the guard row, we do want a visited, but we want it with the same hash set as before. It's basically what we want. So that's what we should have, right? And it's going to say that I can't move a mismatch hash set found reference to hash set. Okay. No problem, I can clone him. So grid, kind of borrow grid as... What is the point? What is the problem here? It's mutable. Well, grid is mutable more than once. What? Okay. Yeah, but now we have... Wait, what am I doing? So we already visited. The guard is there currently. So the guard is overriding the damn thing. That's what's going on. That's what's happening here. The guard is overriding it. So when the guard goes over a visited cell, we're obviously overriding that visited cell with the guard, right? Yeah. So that's something I didn't oversee, which is kind of annoying. So it does work fine, but this is not how it's meant to be working. That's the problem. Because the guard is overriding it. So somehow I have to store whatever the previous guard's position was visited somewhere else. And this is definitely something that's kind of annoying. Oh. Yeah, to give you a little idea of what's happening here. So say the guard already visited this, right? So it's an X here. And the next time they come to visit this one, we turn this one to a visited, and this one is going to be a guard now. So we lost track of whatever was there. So in other words, we lost track of the hash set that was there before. What I could do is, I'm not going to do it right now, but what I could do is like I could add another like visited buffer here into the guard that kind of keeps the previous cells visited information in there. So when they move along, we can transfer that over to the previous cell. That could fix it. However, oh, what am I doing? Is there a better way? A way that's not going to take us like 10 minutes because I kind of want to sleep soon. Let's see. Yeah, no idea how this just appeared out of nowhere. So kind of borrow grid more than once. Yeah, that's because of this, right? I guess. Yeah, that's definitely because of that. Oh. This is definitely annoying. Yeah, what do you guys think? Is it worth? Cody, no review of my code today, seems. Yeah, sorry, GTX. This problem has taken a long time, dude. Next stream, I promise. At the start of the stream, we'll review it. I'll definitely review it at the start of the stream. Like, you could keep a global set that's not cell specific. Yeah, I could do that as well, but then that's gonna add a bunch of overhead. Adds yet another buffer. Yeah, but maybe you are right, Patrick. Maybe I should be keeping the cell information away from the guard, right? Because I'm basically what I'm doing is I'm storing the cell stuff and the guard information in the same grid, and I think the guard should just be, it's just a singleton variable somewhere. It's just a single variable somewhere. It doesn't have to be on the board. What it could have is like I could have a guard struct. So something like a guard obviously has the position, which is an I32, or where it is currently, right? Currently. And I could also have the direction here, where it is walking towards. There, I32, I32. Is it that? Yeah. Wait, what? What's the issue here? Replace that with this. Yeah, so I can have that, and we could completely remove the guard from there, basically, because then the board wouldn't be overridden all the time. I keep that information about where the guard is outside. So maybe that's what I'll do tomorrow. I'm going to unfortunately call off the stream here, guys, because I'm kind of tired, unfortunately. And we've been going for like 2 hours and a bit now. So, yes, boys. I tell you what, thank you all very much for joining, though. Especially you, GTX. Thank you for joining yet again. Dude, you keep joining my streams. And you, Patrick, as well. You joined last stream, so I do appreciate for that. Don't forget to drop your likes, guys. And I will, if you're interested in finding out what happened to the solution, I will probably be fixing it tomorrow morning because I'm going to have some time away from the computer now. Maybe read something. And yeah, once I do it, I'll push to my GitHub repo. So if you are interested, join the Discord. That's what I'm saying. Thank you very much. Thank you for the stream. No problem, dude. I'm always very happy to have you here. Yeah, just join a Discord. Join a Discord. That's all. Anyway, see you guys in a bit.